All right, you guys, we're getting into some stuff that you are definitely going to see on your test tomorrow. Okay, so let's take a look real quick. So first of all, it says, this first part, okay, determine whether the intermediate value theorem would guarantee a C value on the given interval. In order for this to work, you guys, it has to be continuous, okay, on that interval. And the y values for both of these numbers right here have to be on either side of the y value for that. All right, so first I'm going to check to see if it's continuous. Let's look at each one, okay? This is a polynomial. Polynomials are always continuous. So I'm going to say check, that one's continuous, okay? All right, this one, let's see here. We know that the bottom cannot equal 0, so on part B, x can't be 2. Because 2 is in my interval, this one is not continuous. Therefore, I don't even have to do the problem. I just say it's not continuous. All right, I'm not going to be able to do that problem. Okay, this one, the bottom can't be 0, so if I add that over, x can't be 1. Well, that's okay, because 1 is not in that interval anyway, so this is continuous on the interval 2 to 5. Not everywhere, but on the interval we're looking for, okay? So we just got to check that. So I'm not going to do letter B, get rid of this real quick, but I got to check the other two, okay? So now the next thing that I check is this. These are x coordinates. What are the y coordinates that go with those, okay? So this first one is like if I plug in -4, what do I get? So I get 16 plus 16 minus 8. 16 plus 16 minus 8. Okay, so I get 32, hold on, 24. I think. That's some quick math. Okay, now if I plug in -1, I get -1 squared, that's 1, plus 4 minus 8, I get -3. Okay? Is this number between those numbers? Okay, it is. So, because this y value of 4 is between -3 and 24, there has to be a number somewhere in here that will equal 4. Okay? So then here's how you actually solve the problem. The actual solving is I take that and I set it equal to that to figure out what number works. So let me do it over here. X squared minus 4x minus 8 equals 4. If I subtract that over, x squared minus 4x minus 12 is 0. Minus 6 plus 2. And when I factor that, and so my final answer, you guys, is x could be 6 or -2. That's where it's going to equal 4. Now, in my interval, though, well, 6 isn't in my interval, but -2 is. So that's the solution for part A. That C value is at -2. That's a number between those that equals 4. All right, so hopefully like that kind of made sense. Let's check letter C. Let's just make sure we know it's continuous. Let's make sure it works, okay? I'm going to plug in those 2 points over here. All right, when I plug in 2, I get 7 over 1. Cool, cool. When I plug in 5, I get 10 over 4, which is like, oh gosh, 4 over 2, which is like 2.5. Okay, is 3 in between those? It sure is. 3 is in between 2.5 and 7, which means that somewhere that has to equal 3. Okay, so then the actual work of the problem. All right, let me go ahead and do it over here. X plus 5 over x minus 1 equals 3. Now guys, let's make sure we all remember how to solve this. I know a lot of times you guys get to this point, you're like, wait, what do I do from here? If I put that over 1, does that help? We just cross multiply. Okay? So if I go that way and that way, I get, okay, 3x minus 1 equals 1x plus 5. 3x minus 3 when I distribute. Subtract that over 2x equals 8, x equals 4. Okay, is that in my interval? Sure enough. So the C value where it equals that is 4. All right, so the actual part of the intermediate value theorem that we're doing is we are setting the equation equal to that. All right, as long as it's continuous and all that. Okay, cool. You will definitely have a question like this. It says to approximate the instantaneous rate of change. Now, you guys, we don't know how to do that yet. We do not know how to do instantaneous rate of change. But it says to approximate it by finding the average rate of change. This is one of the things you want to have memorized. Average rate of change means slope, okay? Average rate of change means slope. And I'm approximating it at x equals 1, but we're not actually using that. I'm using the slopes 0 and 3. So again, let's get some coordinate points here. When I plug in 0, I get 2. When I plug in 3, I get, let's see, 3/3, 27 times 2 is 54. Minus 9 plus 2, so it's 45, that's 47. Okay, so you guys, my slope is y2 minus y1 over x2 minus x1, 45 over 3. If you're on a free response part of the test, you don't even have to simplify that. Boom, we're done. I mean, if you want to write the average rate of change is 15, you can, but 45 over 3 is good. Okay? So you need to know average rate of change is slope. Definitely want to know that. All right, now we have a couple of like tricky limit ones. Okay, cool. Starting with 49. The limit as x goes to 0, f of h of x. Well, what we want to do, guys, is we want to do the inside first. So let's find the limit as x approaches 0 of h. Here's h. As I approach 0, it's approaching a y value of 1. Okay? So now I turn that into the limit as x is approaching 1 of f of x. And here's 1. As I'm approaching 1 from both sides, that goes to negative 1. All right, so that's how you do these like kind of tricky limits. Okay? Oh, for goodness sakes, that one's a little difficult. Let's see. As we approach 2 of f of x. Yeah, this we're not going to have anything that tricky on the test. Go ahead and skip that. That's crazy. Let's look at this one, though. The limit as x approaches 2, h of x plus f of x. Actually, we're not even going to have anything this crazy either, but let's go ahead real fast and do it. We got to do both sides. Let's try 2 from the left of both of these. Okay, from the left, that's approaching negative 1. That's approaching 3. So together, that's approaching 2. Now we're going to go from the right. H of x plus f of x. That's approaching 3. That's approaching negative 1. 3 plus negative 1 is 2. So even though we think it might be does not exist because they don't match up, it actually does, because when I take the left-hand limit and the right-hand limit, when I add them together, they both equal 2. So this limit does equal 2. Kind of tricky, but we always want to go through and find left, right? Okay? Cool. You will definitely have a question like this on your test. Okay, if the squeeze theorem can be applied, and g of x, f of x, h of x, except at x equals 5, so g of x is less than or equal to f of x less than or equal to h of x, blah, blah, blah. Find limit as x approaches 5 of h, and limit as x approaches 5 of f. Okay, and we know the squeeze theorem works. Guys, what the squeeze theorem says is if I can get that to go to a certain limit and that to go to a certain limit, the middle one also has to go to that limit. Okay, well, let's check this out. Limit as x approaches 5 of g of x. All right? Let me go ahead and write what g of x is. X squared minus 25 over x minus 5. Okay, when I plug in 5, I get 0 over 0. So if I cancel that, all right, Those cross off. Of x plus 5 now. And now when I plug it in, I get 10. So if this limit as x approaches 5 goes to 10, this limit as x approaches 5 has to go to 10, and this limit as x approaches 5 has to go to 10. Okay, so basically the squeeze theorem says if this limit and this limit equal 10, then the limit in the middle has to equal 10. That's it. All right. 53 is a little bit crazy. We're definitely not going to look at that right now. We can look at this one. Okay. Domain. First of all, anything that makes the bottom 0 affects my domain. So x cannot be -1, +3, 1, or 2. That's easy. Those are my discontinuous values, my restricted values, or whatever. Okay, when I reduce this, I could cross out that. Guys, when I cross that out, by the way, that's a hole. A hole at x equals 3. Can't cross that. Okay, I could cross out one of those. So right now I'm saying, yeah, there's a hole at x equals 1. And that's it. So the reduced form of this is x plus 2 squared, x minus 1 over x plus 1, x minus 2 squared. Okay? My holes are at 3 and 1. The stuff that's left on the bottom now, these are asymptotes. So my vertical asymptotes are at -1 and +2. Okay? And I want to talk about end behavior. Now, you can either go from this original problem or from the reduced one. But let's go ahead and say I'm going to go from the original problem. Guys, end behavior means the limit as I go to infinity, the limit as I go to -infinity. Now, check this out real quick. What if we had to multiply out this whole thing? First of all, that would stink. But second of all, here we go. If I multiplied out x plus 2 squared, it would be like x squared and then a bunch of other crap. If I multiplied that out, it'd be x squared and a bunch of other crap. And then this one is just x minus 3, whatever. X squared times x squared times x would be x to the 5th and a bunch of other crap. Okay? Now, if I were to multiply out this one, 1, 2, 3, 4, 5, that's x to the 5th and a bunch of other stuff. So remember, when the degree of the top and bottom are the same, we're going to use the coefficients. Okay? So as x approaches infinity, I get 1 over 1. So that's the end behavior on that side. As I approach -infinity, I just need to check the signs. Okay? That's a 1, not a negative. And negative to the 5th is negative. Negative to the 5th is negative. Negative times negative is positive. That also goes to 1. All right? Don't worry about x and y intercepts. I don't believe I'm asking you that on the test, so that's no big deal. I guess if you're dying to know, basically how it works is when the top is 0, or when the equation equals 0, which is when the top equals 0, or x intercepts. So that's at -2 and 1. Except 1 can't be an x-intercept because it's a hole, right? And then y-intercept is just what I get when I plug in 0. I mean, you could plug it into the original equation, or you could plug it into this equation right here. I basically get 2 squared times -1, 1 times -2 squared. So I get -4 over 4. So the y-intercept is at -1. Okay? Cool, cool. Now, if you were here in class when we did all of these, then amazing. I feel like you're good, and you guys can go ahead and, just finish the rest of your review. If you are not in class, I'm going to go over a few very important questions that you're going to see on your test. If you are in class, you can stay and listen to this also. Okay, so I want to review these a little more. These are the questions that most definitely you will see on your test. So let's take a look at them, okay? And I know there's hardly any space here, but here we go. Okay, for number 5. Oh, well, actually, let me start with this. Really important. Let's write it over here. For a numerical limit, if you get 0 over 0, it's a hole. And the way that you're going to do this problem is by factoring. Okay? If it's a number over 0, it's an asymptote. And the only possible answers for that will be positive infinity, negative infinity, or does not exist. So we'll talk about how to get that, but that's because it's going like to an asymptote like that. Okay? Okay. If you get 0 over a number, it's just 0. I can divide 0 by something and just get 0. That's totally fine. All right? So those are some things we want to remember. Okay, so starting at number 5. When I plug in 2 right here, I get 0. 6 minus 6 over 0. So I get 0 over 0 on this one, which means I need to do this by factoring. Okay? Okay, t squared minus 4 is a difference of squares. And then t squared minus 3 plus 2. Multiplies to make 2 is 2 and 1. To get negative 3 would be negative, negative. And right here, you guys, I can see that the minus 2 cancels out. Now that cancels out, I can plug this in. And I end up getting 2 plus 2 over 2 minus 1. So I get 4 over 1. Okay? So that's how we do one when we get 0 over 0. We do factoring. Next, okay, let's look at number 9. When I plug this in, remember, don't just go, ooh, it's factoring right away. Don't do that. When I plug in 0, or I'm sorry, when I plug in 1 right here, I get 1 minus 2 plus 1. So I get 0 over 1 plus 1, 0 over 2. Guys, 0 over 2 is cool. That answer is just 0. We don't have to do factoring or anything like that. Okay, 0 over a number, we're good. So remember that. Okay, let's look at number 10. Plugging in this one, 1 minus 2 plus 1 is 0 over 0. So this is 0 over 0 again. So I do need to do factoring. X minus 1 over x minus 1. Okay, crosses out, right? Now I go to plug this in, and I get 1 minus 1, which is 0. Again, 0 is a fine answer as long as it's on the top. That's cool. All right. 12. Okay, 13. Now we're going to look at a couple of infinity problems. Do you guys remember that with infinity, you have to compare the degree of the top and the bottom, the highest degree? Well, the highest degree here is x squared. So x squared over x squared, okay? So if I look at this, my coefficients are 1/2. That's what this one goes to. So anytime they're equal on the top and bottom, we just use coefficients. Let's look at 15. If I look at the degrees here, the top is bigger than the bottom. Oh, I should write these rules down for you too, shouldn't I? Let's see here. For infinity. Top bigger than bottom, it goes to positive infinity or negative infinity. Top equal to bottom, it goes to coefficients. Bottom bigger than top, it goes to 0. Okay? Cool. All right. So remember those. So here we are. Okay, x squared and x to the first, the top is definitely bigger. So it either goes to positive infinity or negative infinity. How do I decide? Well, I go like this. If I'm plugging in a negative squared is positive, divided by a negative goes to negative infinity. So that's the one I would pick. So you just check the signs, okay? 16. Okay, let's take a look at 17. Now, when I plug in 2, for right now, don't really worry about this minus thing. That only matters with asymptotes. So let's see if it even matters or not. When I plug in 2, I get 2 over 0. So sure enough, this is an asymptote, okay? This is an asymptote problem. With an asymptote problem, if it's a one-sided limit, it goes to either positive infinity or negative infinity. Like, think about the asymptotes that you know, right? It either goes like that to negative infinity or like that to positive infinity or something. If it's a double-sided limit, it usually does not exist. Like this, if I just said as it's approaching 2, it doesn't exist. But this one is going to go to either positive or negative infinity. How do I decide? Well, you could graph it, but if this is on the no calculator part of the test, which it would be, okay, here's what I would do. What is slightly to the left of 2? Okay, slightly to the left of 2, 1.99. 99999, whatever, okay? when I plug that into the top, I get a positive number. When I plug that into the bottom, well, all I know is 1.99 is less than 2, so 1.99 squared is less than 4. That's going to give me a negative number. And a positive divided by negative is negative. So that asymptote's going to go to negative 30. Okay? Okay, there is one limit that asks you to evaluate at a point, at a trig point. It's in the first quadrant, so as long as you know your best friend chart, you're fine. Pi over 6, pi over 4, pi over 3. Okay, if you bring your own best friend chart, I will let you use it. Sine, cosine, tangent. 30, pi over 6, pi over 4, pi over 3. And it fills in like this. 1 over 2, root 2 over 2, root 3 over 2. 3 over 2, root 2 over 2, 1 over 2. Divide those. That's 1 over root 3, 1 root 3. At pi over 4, that is this column right here. Okay? Tangent of pi over 4 is 1. Cosine of pi over 4 is root 2 over 2. Sine is root 2 over 2. Guys, on a free response question, meaning it's not multiple choice, you may leave your answer like that. Absolutely. You never have to simplify, okay? So any question that's not multiple choice where you're writing your answer, you can leave it like that. If this were multiple choice, right, it would probably, I'm thinking like add those together. 1 root 2 over 2 and 1 root 2 over 2 is 2 root 2 over 2, which would then cancel out, right? But on a free response test, you don't even have to do that. You just got to get your answer there, okay? Last question. This is a little hint for anyone who watches the video to the very, very, very end. I believe we talked about this, so we're going to talk about it again, okay? Absolute value of x over x. Let's talk about this graph real quick, guys. If x is a positive number, do you agree that the absolute value wouldn't do anything? So as long as x is a positive number, it's just 1. And what happens is this graph comes in like this at 1 for all these positive numbers to an open circle, okay? Okay. If it's a negative number, do you guys agree that it would be the opposite? Like if it was negative 2, absolute value changes to positive 2. If it was negative 3, changes to positive 3. So it tends to be negative x over x, which is negative 1. So what that means is it comes in at negative 1. Like that. That's what this graph looks like. If you guys know what this graph looks like, you can kill this problem every single time. Okay? Now, let me show you something real quick. Show you that I'm not lying. Here's what this graph looks like. Okay? Not that I would ever lie to you, children. Oh, crap. Okay. Fraction. Absolute value of x over x. Okay? So 1 approaching in at 1. 1 approaching in at negative 1. So if I'm finding the limit, all right, any left limit will be 1, any right-hand limit will be negative 1, any right-hand limit will be 1. Okay? Now, what happens when I move this? Let's say on the inside I put plus 3, plus 3. Well, guys, plus 3 is just going to move it to the left 3. And so it's doing the same thing, negative 1 and positive 1, but it just moved it over to where the negative 3 is. Let's say I put on here minus 5, minus 5. What's that going to do? This is going to move it to 5, and then that's where it splits up from negative 1 to 1. If you know this, this almost always is on a multiple choice part of a limits test. So if you know it, it's so easy. So like, look at this. So this question, as x approaches 0, does not exist. Okay? But let's say I'm doing that from the right. All right, let's say I'm doing that from the right. Because you know it's 0 over 0, so it obviously doesn't exist. But from the right, all I want you guys to remember is, okay, the left side goes at negative 1, the right side goes at positive 1. So the right is positive 1. This exact same question, because it's on the right side of the graph, this exact same question, limit as x approaches 4 from the negative side of, I should write that okay, from the negative side. Well, what that means is the negative side is coming up here, the positive side is coming up here. What's that one going to? Negative 1. Just by knowing what the graph looks like, okay? So that's a little hint for you. Every question like this, approaching from the right is positive 1, approaching from the left is negative 1. All right, if you guys watched both videos and did the whole review, I think you should be chilling for this test, okay? Great work, guys.